Hello, everyone, and I hope everyone is having a good day. Let's continue our talk, and this is going to be one of our last, if not our last, lesson about solutions. And today we're going to be talking about electrical conductivity. Fact. It is a well-studied fact that pure water is electrically insulating, meaning that pure water doesn't conduct electricity. Now, hopefully you're thinking to yourself, but Mr. Sherber, we know that if you stick a running toaster in a bathtub, you can get electrocuted. Yes, that's true. Please do not dump toasters in bathtubs. But that has to do with the fact that, and the key word here is pure water. That the water coming out of your pipes is not pure water, it's water with salts. It's salt water that's electrically conductive, not the pure water. It has to do with the mixture of the two. And that's what we're going to be talking about today. And to start with it, let's define a couple of terms. And the first term we have electricity. And electricity comes from the flow of any charged particle. Now, our wall outlets, the ones that you use every day, and our batteries and our electronics, we can say every day electronics run on a flow of electrons. That's what comes out of the wall when you plug something in. That's what is coming out of a battery when you put it in. That is, what is in a car when the car engine turns on. It is a flow of electrons. But you can also get electricity from a flow of protons. It doesn't happen as much because they're less stable on their own, I guess. But it is possible, and it has happened. But mostly we talk about flow of electrons, but technically electricity, flow of charged particles, like I said. Now, the term electrical conductivity, to conduct electricity, really means if something is electrically conductive, it means it has the ability for charged particles to flow through. And it is very common for us to relate electricity to kind of like water. So we have a couple of water droplets, and if we try to force those water droplets through a closed pipe, what's going to happen is the water droplets are going to hit the pipe and just bounce off. So we would say that this pipe is non-conducting. It is impossible for the water to go through the pipes. The pipes are rejected. The water molecules are rejected. We have the same situation. We have another pipe. Instead of it being a solid pipe, it is a hollow pipe. Now the water can flow through this hollow pipe. So we would say this is electrically conductive. So as long as the electricity, the particles, can flow through it, it's electrically conductive. Solid salts happen to be insulators. A solid salt will not conduct electricity. And that has everything to do with the shape of the crystal. Hopefully remember that the crystal lattice structure looks kind of like this, right? The ions are trapped in place. They can't move. So if an electron were to try and go to there, which is boop, bounce right back, right? Not electrically conductive. Water is the same thing. Draw water. Pure water, an electron tried to go through it, bounce right back. Pure water is also electrically conductive. I'm sorry, electrically isolated, insulating. Something really cool happens when we dissolve salt in water. What I'm going to do is I'm going to redraw my water molecule, two water molecules, and I'm going to put in their partial charges. So we'll have the positive, I'm sorry, the oxygen and the hydrogen. That's going to be a partial negative, partial positive, partial positive. Here's another water molecule. Partial negative, partial positive, partial positive. And what's going to happen is when these water molecules come to this solid salt lattice, this solid ionic lattice, it's actually going to help to pull it apart. It's going to make it so the ions dissociate. Water makes ions dissociate. Literally, they're not as connected together. So we're going to have a cation up here. We're going to have an anion down here. So if we were to look at this in kind of a bigger scale, I would draw out a beaker. And has water in it. Really what's going on is that I'm going to have a whole bunch of ions. That are just kind of randomly moving around. And we say that the ions are when dissolved, the ions are, this is a key term, free and mobile ions. Those ions are now free to move around. Hey, remember how we defined electrical conductivity as the ability for charged particles to flow, right? Look at that. We now have a situation when that salt water is dissolved, when those ions are disassociated and freely floating around, we now have ions with the ability to move, electrically conductive. So now electricity can flow through here. Now, while solid salts can't conduct electricity, we know that solid metals can. Why can solid metals conduct electricity? even though solid ionic compounds can't. And it all has to do with that structure, that crystal structure. So for an ionic compound, remember that it looks like this, like we just drew before. Plus, plus, minus, minus, where we have all of these ions held in place. For a covalent compound, it's very similar. All the atoms are still held in place. All particles in both of these substances are really bonded in place. Yeah, there's a very small amount of movement, but not much. Hopefully we remember metals. For metal, pure metals, they're a little bit different, where we have a whole bunch of cations. But we said that when you look at the electrons actually can be anywhere. So electrons in metal can move anywhere. The electrons are free flowing. And so if we have electrons from the outside, it can totally flow through. Unlike if electrons from here, they would bounce off because they can't flow through. And same thing with our covalent compounds. Our electrons would still bounce off. So because the metals have that sea of mobile electrons, because the metals have those electrons that can move around, solid metals can conduct electricity. Solid salts cannot. However, liquid salts actually can. If you were to melt sodium chloride down, you can have an electrical current flow through it. Okay, and that is going to be the end of our lesson for today. I hope you enjoyed this, and I will see everyone in class tomorrow. Bye.